Hello everyone, in this video I explain some application problems of derivatives. And the first one is find the equation of a tangent line to the graph of this function, and the function is 3x squared minus 5x plus 2, and we need to find the equation of line tangent to the graph at the point x equal to -1. So x equals to -1, so it means somewhere here, and this point is -1, and the y value will be f of -1, and we need to find the equation of tangent line at this point. So we know that the equation of any line, or in this case equation of tangent line, would be given by y is equal to mx plus b. So where m is the slope of tangent line and b is the y-intercept of tangent line. So we can find the slope using our knowledge of derivatives. So slope is the derivative of fx, and we want this derivative at the point x equals to -1. So our fx is 3x squared minus 5x plus 2. So the derivative would be 6x minus 5. And since we need slope at x equals to -1, we can plug in the value x equals to -1 here. So we get our slope at -1 would be -11. So this is the slope of tangent at x equals to -1. So using the slope in our equation of tangent line, or line number 1, we get, so therefore tangent line becomes y is equal to, slope is -11 x plus b. So now our only goal is to find b. So in order to find b, we can use the information that the point -1 and f of -1 lies on the line. So can plug in these values in the line. So let's first figure out our point -1 and f of -1. So when x is -1, f of -1 would be, so we plug in the value in the given function. So 3 times x square means 3 times -1 square minus 5 times x -1 plus 2. So overall we get, so 3 plus 5 plus 2, so we get 10. So the point is -1, 10. Point -1, 10 lies on the line. So we plug in the values in this line. So we put x equals to -1 and y is equal to 10 on this line. Therefore, this line implies, so y is equal to 10. So -11 times 1 plus b. So from here we get, so from here we get 10 is equal to 11 plus b, or b is equal to 10 minus 11. So this means b is equal to -1. So our y-intercept is -1. So now we put this value back in here. So it means our equation of line becomes, therefore equation of tangent line becomes, so y is equal to -11x and b is -1. So this is a required equation of line that we were looking for. So just a recap. So we used the derivatives information to find the slope of this tangent line, and then we used that this point lies on the line. So we used that information to find the y-intercept, and we got our equation of required line. So let's do one another example. So in next one again we have to find the equation of a line tangent to the curve at the point 1, 0. So this is our point 1, 0, and we need to find the equation of tangent line. So we know that the tangent line would be given by the equation would be of the form y is equal to mx plus b, where m is the slope and b is the y-intercept. And for slope, we use the derivative. So we're going to find the derivative of the curve at the point 1, 0, and then we can find the y-intercept using the information that the point 1, 0 lies on the curve. So in order to find the derivative or the slope, so we know that this is of the form u times v, so we can use our product rule. So the derivative would be 1d2. So first function as it is, derivative of second plus second function as it is, derivative of first. So we know that the derivative of x square is 2x, derivative of 3x would be 3, and then derivative of 2 would be 0. Similarly, we have, so derivative of x cube would be 3x square, and derivative of 1 would be 0. So now we can simplify this, and so using the foiling method, so we get x cubed times 2x, 2x4, x cubed times 3, 3x cubed, minus 2x, and minus 3. And then similarly we get 3x4 plus 9x cubed plus 6x square. So now we're going to combine any like terms. So in this case, 2x raised to power 4 plus 3x raised to power 4, we get 5x raised to power 4. And then for the cube terms, 3x cubed plus 9x cubed gives us 12x cubed. So 12x cubed. And for square term, we have only one term, 6x squared, and then minus 2x and minus 3. So this is our derivative. But we want to find the slope when x equal to 1. So slope when x equal to 1, so just put x equals to 1 here. So we get 1 raised to power 4, 12 times 1 raised to power cube, and then 6, 1 square, minus 2 times 1, minus 3. So now this is slope at x equals to 1. So remember, so this is our slope of the function. So this is our slope function. So at any point, but if you want at a specific point, we plug in the value. So this is slope of tangent at x equals to 1. So this is what we need. So 12 plus 5, 17. 17 plus 6, 23. 23 minus 5 would be 18. So we got slope equals to 18. So this is your value of m, or slope. Therefore, our line y is equal to mx plus b becomes, so y is equal to 18x plus b. So this is our tangent line. And now we need to find the value of b, or y-intercept. So we use the fact that point 1, 0 lies on the line. So point 1, 0 lies on tangent line. So we plug in the value. So when x is 1, y is 0. So 18 times 1 plus b. So from here we get b is equal to negative 18. So now we put this value back here. So therefore Therefore, equation of tangent line at 1, 0 is given by y is equal to 18x minus 18. So this is our required solution. I will do few more examples in the next video, so please keep watching.